All right, so we're going to take a look at a couple of SAT problems. These are two on the math without calculator section. We're going to take a look at a couple of these problems that are among the more difficult problems to do. But if you have a good approach, you'll be able to do them fairly quickly. So this is number 14. And number 14 gives us this kind of scary looking fraction and gives us a parameter, and it says that a is greater than 5. And it tells us, and it asks us which one is equivalent to 1 over a plus 5 plus 1 over a plus 4. So, I mean, you can do this theoretically, and you can kind of find it using a, but in this situation, if there's a variable and they give me a parameter this wide, I just pick a number, just plug in something that will let me know. So I got to keep in mind. So I'm going to choose in this case the most basic thing, a equals 6. So I'm just going to plug in 6 for wherever I see a, and then I will plug in to my answers to see which one will work. But remember, also we're using elimination strategies to eliminate. So we're not having to plug in all of these answers, just a couple of them, and actually only one. So the actual math, we're going to start in the denominator of this big fraction. And then this 1 over just means that whatever we get when we solve this, we're just going to flip it. Okay, so 1 over all of this stuff. So first I'm going to take, if a equals 6, I'm going to go 1 over 6 plus 5. Plus 1 over 6 plus 4. So that would be 1 over 11 plus 1 over 10. When we're adding fractions, we have to get the lowest common denominator. And in this case, when numbers are just separated by 1, like 11 and 10, the easiest way to get the lowest common denominator is just multiply them together. So I'm going to go 10 times 11, and that's pretty easy, right? I don't need a calculator for that. So I know that my answers are going to have 110 as their denominator. So 11 times what gives me 110? 11 times 10, so I multiply the 1 on the top there by 10. And then 10 times what gives me 110? 10 times 11, and then I multiply the top by 11. So, right, 11 times 10, 10 times 11, 1 times 11, 1 times 10. All right, so that gives me, what I get there? 10 over 110 plus 11 over 110. 10 plus 11 is 21. All right, and so remember what I said earlier, 1 over that just means I'm going to flip it. So that is 110 over 21. All right, so I look at my answer choices, and I know that, first of all, my answer is going to be a fraction. So A is out and C is out because those aren't fractions, right? So I'm going to choose one of these and pick and see if, okay, which one is going to give me 110 on the top and 21 on the bottom. And I'm going to guess. And if I get it, then I choose that one. If I don't get it, it's the other one, right? So I'm going to choose, I'm actually going to choose D because I think that if I'm going to square my number, I'm going to get a bigger number on the top, right? And also, just to avoid any potential errors, I'm going to choose the simplest one, 2a plus 9. If 2a plus 9 gives me 21 when a equals 6, then I know I've got the 1. 2 times 6 is 12. 12 plus 9 is 21. So I know that D is the right answer there. Does that make sense? So, okay. So now we're going to go over to, I'm going to erase some of this here and go over to number 15, which is quite complicated. It is just this is one of those that you may want to even just like skip over until you get, and leave it until you know that you have time. All right. So here I'm given a quadratic. Sort of, but it's kind of in a weird position. It's got a couple of variables, and so it just is weird. Um, it says that Q and R are constants. What are the solutions for X? All right. So if I look at this, um, I, I I don't know. I mean, looking at it off the top of my head, I have no idea. I would factor this. If it was a regular quadratic, I would just kind of pull up my reverse FOIL and kind of go at it that way. But it's hard to do that with something like this. And then I look at my answers. My answers, I so there's some dead giveaways here, right? Plus or minus, square root. I know I'm going to have to do something with the quadratic formula, right? If you don't remember the quadratic formula, you have to remember it for this. This is one of those like essentials, right? Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so another difficult part about this is what's my A, what's my B, and what's my C. So I've got to rearrange this. This has to go over to join its buddies. And so this is going to be our X term. So this Q over 3 thing, I'm going to add Q over 3X to both sides and give me X squared plus Q over 3X plus 1/2 R equals 0. So in this case, if I'm going to put things in the quadratic, A equals 1, B equals Q over 3, C equals 1/2 R. It's that whole thing because it's the constant, right? So if I'm going to put those things into the quadratic formula, I'm going to get negative Q over 3 plus or minus the square root of Q over 3 squared minus 4, 1/2 R all over 2a. All right, so I've got some nastiness in the actual square root there. I'm going to simplify, and 4 times 1/2, that gives me 2. And so I'm going to simplify the Q over 3 squared. Q over 3 squared gives me Q squared over 9, right? So I'm going to just Q over 3 squared equals Q squared over 9, which my 9s look like Qs and my Qs look like 9s, so sorry about that. And then I'm going to change all of this in. I'm just going to erase real quick. All right, so that's going to give me, okay, love the big eraser. So that's going to give me Q squared over 9, not over Q, over 9. That is so confusing. Minus 2R. All right. So if I look, first of all, if I look at my options here, I know that my Q over 3 is further divided by 2. So I know that my answer is going to involve 6 somehow. Q over 3 divided by 2, that's going to be negative Q plus or minus, and then it's going to be a denominator of 6. All right. So I'm going to put all my 3s on the bottom there. But then this is the tricky part here. I have to factor out. I have to change this to like 1/9. Got to factor out a 1/9 from this middle term here, because 1/9 is a perfect square, and I can pull that out from underneath this. Does that make sense? So if I'm going to simplify this, this is going to be 1 over 9 times Q squared minus. So 1/9 times what will give me 2? 1/9 times 18 will give me 2. So this is the same thing as the square root of 1/9 times Q squared minus 18R. So that's where the fraction actually goes. So then I can pull that out. That's going to give me my 1/3. The square root of 1/9 is 1/3. So then that would be outside of the square root. And then again, further divided by 2, that would give me that 6 there. So that leaves behind q squared minus 18r. So again, I ruled out C and D because I knew that it had something to do with something over 6. And then I knew that I was going to have to pull out a 1/9. So I didn't even have to like finish that calculation. I knew immediately that it was going to be A. It's going to be q squared minus 18r over 6 there. Okay, so those are two pretty hard ones. I would say, like I said, leave a couple of these for the end of the test. I would skip over these to go to the gridded response and then come back to them, because you don't want to spend too much time doing ones that, okay, you know that you might be able to get it, but then what happens if you are wasting a little bit of time, and you end up not giving a full thought process to ones on the gridded response that you know that you can get. So that's a good strategy reminder to make sure that you go to the ones that you can get quickly and then come back to the ones that you need to do a little bit more thinking on. All right, so those are 2 hard problems for today. I'll do a couple of other hard ones as we go along this week. So thanks so much for watching. We'll see you next time.